This 3D geometry problem involves Pythagoras and involves trigonometry. You were presented here with a triangular prism and you have a fully labelled diagram, and you want to find the angle between AD and the base ABEF. So we can see the base here, AD, and this is an important bit here, AD is on the surface of the prism. It's actually on the face ACDF. So often when we do diagonal lines, finding the distances or angles in 3D, it's a cuboid and it's going from one corner to the directly opposite corner, not on a face, but here with the prism it's actually on the face itself. I'm going to draw that line in blue. So we've got AD here, and we want the angle with the base. So if we drop from D straight down, drop a perpendicular here, that will bisect FE, so at the midpoint, so I'm going to call that M, and then I go from that point there all the way back. And what I've done is I've created a right angled triangle here. So that triangle, if you sketch it, it's going to look something like this, where D, M, as the point I've created there is the midpoint, and A, like that. And the angle I want is this angle here. On my diagram it will be here. So what information do I actually know? Initially I know very little, but I want to find, I need two sides to find the angle. That's what we need for trigonometry. The two sides I'm going to work on are going to be DM and also AM. Now DM comes from this triangle here, and that should work out quite nicely. So let's just draw that triangle on the left hand side here. I have D at the top, M, which is my midpoint, my perpendicular bisector there, and that is E. I have 12 here, and length ME is going to be half of FE, and FE is the same as AB, so half of 10 is 5, so that is length of 5 centimeters. And so I just want to find DM, and that's going to be a Pythagoras question. So dm squared will be equal to 12 squared plus 5 squared. Dm squared, or dm rather, is equal to the root of those two, 12 squared. So that should be minus, my apologies, minus 5 squared. And dm therefore works out to be an answer of root 119. I'm going to leave it in root form so I have a very, very accurate answer at the end, rather than writing it down to any form of significance just yet. So I have the first of my measurements here, I have the height, so I'm going to write that one on. This is root of 119. Now I want to find the next length, which is AM. So AM comes from the base of the rectangle, the rectangular face here. So it's the diagonal, so I'm going to draw a little triangle here, AFM, like this. AFM is a right angled triangle because it's a rectangular face, and I know that AF is going to be the same as BE, so that's going to be 15. FM is the same as ME, which I know is 5, and I'm trying to find the long side this time, so it's Pythagoras again. AM squared, try not to make the mistake I made just now. AM squared is equal to 5 squared plus 15 squared. So AM is equal to the root of those two, 5 squared plus 15 squared. You work that through, AM is equal to the root of 250. Again, leave it in that form, is good enough. So now I can write that onto my triangle at the top here. This is root 250. And now I'm going to use my trigonometry. I'm going to call the angle x. I'm using the opposite, I'm using the adjacent, and that is tan. So I can write the tan of x is equal to the opposite, which is the root of 119, over the adjacent, which is the root of 250. So x is equal to tan to the minus 1, or if you prefer, arctan of root 119 over the root of 250. And when you put that into a calculator, you get an answer of 34.602 and a whole bunch of other stuff. I wanted to 3 significant figures, so x is equal to 34.6 in this instance.